Okay, guys. So in this video, I'm going to make just a quick video. The first thing I want to do is review a little bit of what I've talked about in the last video with respect to combining vectors. And then what I'm going to additionally show you is an additional tool which we haven't discussed yet. So one little new nugget of information that will relate to how to find the direction of a resultant vector when you combine two or more other vectors. So I want to start with this problem here. We've got Jones, and it says that he walks 2 kilometers in a direction 60 degrees east of north, then turns and walks 4 kilometers due east. And what we're asked to find is the displacement vector for his walk. Now, we can set this up, we'll draw it up, and hopefully nobody will have any difficulty at this point finding the magnitude of the displacement vector. We talked about that. We're going to see this is going to turn out to be a law of cosines problem. That hopefully everybody has a handle on that. What we haven't discussed is, in order to find the displacement vector, I need to have a direction as well. And it probably is clear to you at this point that when you're dealing in 2 dimensions, positive and negative is not a sufficient way to measure the direction of a vector. We need to have an angle. When we do this problem out, we're going to see that the angle is some degree, north and east, but we have to figure out exactly how north, exactly how east the resultant is. So I am going to get to a point where we're taking a look at the direction of the displacement vector as well. But let's get started. First of all, let's make sure that we can decode what this question is asking. So we've got Jones. Initially, he walks 2 kilometers in a direction 60 degrees east of north. Well, I'm going to call north up. Makes sense. When I think about the compass, I think of north as up. So 60 degrees east of north means this. This is my vector. Let's call it A for the purposes of our calculation. And this is 60 degrees north of, or east of north, meaning that this angle right here is 60 degrees. That actually looks closer to maybe 45 or 50 degrees, but at any rate, it's supposed to be 60 degrees east of north. That's, when you read this, east of north means I imagine going north, and then I turn 60 degrees to the east of north. So hopefully you can see how that direction, east of 60 degrees east of north, allows me to figure out that that's the angle I'm talking about. Then he turns and walks 4 kilometers due east, so that would be this. And that's B. We'll call that B for the purposes of our calculation. So we're saying A is 2 and B is 4. And then we're asked to find the resultant vector. Well, we can draw this, right? Here's the resultant vector. There. That's the resultant. That's the overall displacement represented graphically. But of course, we want to figure out what is the value. First of all, how long is that arrow? What is the total displacement distance here? And then, as I said, we will get onto direction in a few minutes. But for right now, let's see if we can calculate the magnitude of r. I'm going to do this quickly because we've already gone over the law of cosines. We know that r squared is going to be a squared plus b squared minus 2 times a times b times the cosine of theta. Now, there is a little bit of an additional step here, and that's that we don't know theta. Theta is not 60 degrees. Remember that theta is the angle between the vectors when drawn tip to tail. That's theta. Theta is not 60 degrees. So we have to find theta. It hopefully isn't too tricky to see the math here. There's a little bit of trigonometry on this. I've got a right angle, or a right triangle right there. This angle here must be 30 degrees. That angle right there is 30 degrees. We know that the sum of all the angles in a triangle adds up to 180. So if I have a 90-degree right triangle, these 2 angles here, the 60-degree angle and the 30-degree angle, have to be complementary. So if the given angle there is 60 degrees, then the other angle must be 30 degrees. Hopefully that's clear. Well, that means that theta and the 30-degree angle must be supplementary. They must add up to 180, which means that theta for our problem must be equal to 180 degrees minus 30 degrees, so 150 degrees. Went over that fairly quickly, but hopefully you can see the geometry here. It's not too tricky, I don't think. So now I can go ahead and calculate r squared, or r. R squared here is going to be 2 squared plus 4 squared minus 2 times 2 times 4 times the cosine of 150 degrees. A is 2, B is 4. Plug in my numbers, and I see that r squared ends up with a value. R squared is about 30, this must be r squared, is about 33.85. Take the square root, and we see that r, the resultant, has a magnitude of about 5.8 kilometers. So there's our resultant. Again, hopefully you guys are pretty comfortable with the law of cosines here, establishing the magnitude of the resultant. How big is the resultant? Hopefully I didn't make another mistake in my calculation. Hopefully that's right. 5.8 certainly seems reasonable. A little bit of extra work in this problem because we did actually have to calculate theta. In previous problems we haven't had to calculate theta, but here we did. Hopefully that's clear to you as well. We're going to move on in just a second here to the next step, which is to find the angle. But I'll give you a minute to sort of sort that through, and then we'll move on to finding the direction of that vector. All right, so we need to figure out the direction. So that means to figure out the direction of the vector, I want to find an angle in here. I want to find, I'll use green. I want to find this angle right here. This angle, for now, I'm going to call it phi. That's the angle phi. So there's phi. We need to figure out that angle. We need to figure out what that angle is in order to have some understanding of the direction of the vector. So I want to figure out the angle phi. Now, to do this, it's a piece of math that I'm sure you've all learned before, but I do want to review it. And that's, we need to know the law of sines. So let's go over the law of sines. We'll get back to that problem in a minute, but I just want to make sure that everybody understands the law of sines. What the law of sines tells us is if we have a triangle, let's say I've got a triangle here, so we've got a side here and a side here and another side here. Let's call this angle here theta. Let's call this angle here, or this side here, r. We'll call this angle here little a, which is opposite from side big A. And this angle here is b, and this is side big B. So you can see we've got 3 different angles. Theta, which is opposite from r. Little a, which is opposite from side big A. Angle little b, which is opposite from side big B. Hopefully that makes sense. You probably used A, B, and C when you learned this in math. I'm using theta and r because for the purposes of vectors, we use theta and r for resultant. And now what we can see here is what the law of sines tells us is that r, the length of that side, divided by the sine of the angle theta, is going to be equal to the side A, side length A, divided by the sine of angle little a, which is equal to side length B divided by sine of little b. And hopefully you've learned that before, but this is a relationship between the sides of any triangle and the corresponding angles of that triangle. Again, I'm sure you've seen that before, but let's apply the law of sines to our problem that we had here of Jones walking. We want to figure out this angle phi in this problem. So to find phi, I'm going to take into account that I know theta. Theta is 150 degrees. I know r is 5.8. I know the length of vector b, right, that's 4, and I know that phi is the angle opposite that. And so what I can say here, according to the law of sines, is I can say that 5.8 divided by the sine of 150 degrees, so I have theta, this is theta over r, or r over sine theta rather, r over sine theta. I'm going to set that equal to b, and b in this case is 4 divided by the sine of phi. And now I'm looking for phi, so I have this relationship, right? I know the side length r, I know the sine of theta, I know the side length b, and I'm looking for the sine of phi. Hopefully that makes sense. So now I can cross multiply here. I'm going to get 4 times the sine of 150 degrees equals 5.8 times the sine of phi. Okay. I do this out, and I'm going to get the sine of phi. If you do out some of the math here, I'll sort of leave you to it. But the sine of phi, after you do out your calculations, is 0.345. And now to find phi, I need to do the inverse sine, or what's called the arc sine. I have to take the arc sine, the inverse sine of both sides. I know the sine of phi is 0.345, but what does phi equal? I have to take the inverse sine, or arc sine of both sides. So I see that phi equals the arc sine of 0.345. Plug that into your calculator, and you find that phi, this angle here, ends up being about 20.2 degrees. So that's a little bit of a primer, an introduction to how you can find the angle of a resultant when you're combining two vectors. So we've got the law of cosines, which allowed us to find the magnitude of the resultant vector. And now here, we use the law of sines to figure out the direction of that vector. So this will allow you to get a full answer to the question, what is the displacement vector for his walk, right? That was the question right here. What is the displacement vector for his walk? So now you could say the displacement vector is 5.8 kilometers at an angle of 80.2 degrees east of north. I added the 60 degrees here, the 60 degrees, and the 20.2 degrees to get the direction. So the full answer here is 5.8 kilometers at an angle of 80.2 degrees east of north. Hopefully that makes sense. I'll leave you to review.